Thank you very much for your kind presentation. Thank you for being here so late. And my name is already given. I'm a professor at the University of Bologna. The paper was co-authored by my colleague Barbara Cimatti and my collaborators, Mattia and Mele. We together are working in a small research group, and we are focusing our work on the application of artificial intelligence tools in manufacturing. This is the outline of the presentation. I modified the presentation by introducing an example at the very beginning of our recent work, because it is exactly in the same topic of the paper that was more theoretical. So the example helps in order to understand the idea, the concept of the paper. So the first part will be this example, this proposal for an integrated innovative system, and question also. Then we will discuss briefly the evolution of computer-aided systems for design and manufacturing together. The knowledge-based engineering system, the evolution, the possible evolution of this system in the future as possible smart integrated systems, and a comparison between different aspects related to design manufacturing approaches. So, first of all, the example I mentioned before. This is our proposal of a knowledge-based engineering system. As usually, there's a level. In this case, this system is focused on the use by a designer. So the input level is a number of, for example, machinery and materials, because we are pushing the choice of available machinery in the machine shop and available materials for the product development in the preliminary phase of the project. So this constraints, manufacturability constraints will be taken into account in the level, and the core of the system is of course an inferential engine, and the object, the function of this engine is to generate a number of automated geometries. Of course, there's the contribution of the designer in order to realize the geometry, and a number of calculations are automated in order to validate and to verify some aspect. I will discuss briefly in the next part this concept, and an optimization in order to choose the best solution, and the output level will be digital output. In this case, we used a simple product, a simple bottle design. So the system used a high-level computer-aided design template that is integrated in a computer-aided design system. The designer needs just to move some of the point of this spline in order to realize the profile of bottle, the axis-symmetric profile. Of course, you can use a number of this profile in order to realize a more complex geometry around the axis. So, the automation concerns a validation about the resistances of the bottle and some simple calculation, like for example the thickness of the walls. So the top load and the inner pressure are not a problem of the designer, and in this case a preliminary evaluation is done automatically. It means that you will have at your disposal a digital mock-up of the bottle design as quick as possible, just moving some points in this part of the system. not fully satisfied by the functionality of the tool. Of course, already some functions were automated, but lack was present in our concept, and particularly the emotional impact of the design was not included, is not included usually in computer-aided design system or computer-aided engineering system. The idea was to realize a number of digital mock-up, 37. In this case, we realized 37 digital mock-up by means of the system, and we adopted the Delft engineering. Probably you know this type of approach is coming from Japan. The idea is to develop and improve products by translating emotional impacts into the domain of product design. Usually you can use, for example, design of experiment, analysis of the variance, and different methods in order to realize this inclusion. We used a number of semantic and antithetical adjective pairs, for example, disposable against lasting, retro against futuristic. And we realized a questionnaire, and we gave the questionnaire to a uniform population, in this case of a number of students of our school, and they gave their reply to our questionnaire. We had a number of evaluation of each of the pairs by means of a Likert scale. This is, for example, a result of the lasting against disposable for bottles. This is the digital mock-up number 1, reached a high level of the lasting adjective, while this bottle is just a rendering of the bottles, reached a lower level because, of course, it seems to be a polymeric bottle. This is the map of all the reply of the students to our questionnaire. At the end, we used an artificial neural network, so we developed an artificial intelligence tool based on artificial neural networks. The best architecture contains 9 neurons in the first layer and 5 neurons in the second layer. Sorry, there's a mistake here. And the input layer are all the geometrical parameters of the sketch bottle. So it means also the volumes, the position of each point in this part of the all the geometrical input are included as the input of the neural networks. The output are the emotional impact depending on each semantic pairs. So this is the system. You have to modify the point. If you are a designer, you can choose different aspects, also structural requirement, and at the end, after the realization of your digital mockup, you can push this button and you can have also a prediction of the emotional impact of the bottle. You have a score, a sort of display like that with different position of each relevant reply. So you can compare different solutions depending on the prediction of emotional impact. So this is an approach, an automated approach. It includes explicit algorithm implementation, so is an integration between computer-aided design and computer-aided engineering system by means of a rule-based system. It's a rule-based system essentially, but also it includes some intelligence like the artificial neural network, in this case a case-based system. So this is not still a smart system because it lacks the interaction by means of sensors and something like that. The idea is to use, for example, a camera to pick the face of something looking at the bottle, a digital mock-up, in order to have a prediction of the impact of the bottle, for example, but is not still implemented. So this is an hybrid system that included the integration of several different tools. Is this partially automated assistant for bottle design enhancing design creativity, or is a limiting factor? This is one of the questions we are facing. So, what about the evolution of the computer-aided design system? This was my first phone in 1998, a very famous one, produced by Nokia, and this is a more successful mobile phone too, produced today. So, product development, as we perfectly know, means an integration between design, I put materials in this way, but of course it's an important input, and the manufacturing. All these aspects have to be integrated. Another question should be, are the systems we are using changing as rapidly as the development needs? I don't know. If I consider Siemens, probably yes, but I'm not sure. Or another question should be, product design is changing rapidly due to the advancement of technology, or the advancement of technology are pushing the change of product design? Again, this is not easy to reply. So, the traditional, I must say probably old approach to product development is a linear one. It's not necessary to discuss this approach because each phase has to be completed before the following phase can be implemented. So designer act as the first player, engineers act as the second player. Sometimes they fight because the solution is not as valid as expected, and again the engineering or the manufacturing shop can have something to modify, can ask some modification to the project. So this traditional approach is very complex. Today, luckily, the digital information are available during all the manufacturing process, during all the development, the product development, and it means that it is possible to integrate each phase in a concurrent engineering approach. And again, this digital information that are available in each phase of product development allow in the integration of these tools, and this integration is helpful. But some scientists also argue, for example, an important philosopher said, argue that the use of computer-aided system, digital system generally, reduces the creativity of designers. So it means less creativity, less variety of products. A knowledge-based system is, again, as I already explained, data input, output, a knowledge base, and an inference engine. In this case, this paradigm is already appeared in the 80s. Is based on knowledge database, and there are several different applications and different acronyms also to describe this type of application: knowledge-based system, knowledge-based engineering systems, and so on. This system includes a branch of artificial intelligence, but for example, the expert system just formalize, manage and apply the knowledge of an expert. It means that explicit algorithm and rule-based are the focus of this system. Machine learning techniques such as artificial neural networks, for example, have been applied to realize knowledge extraction from database. It means case-based system that needs an experimental activity before this implementation. Today, machine learning is, of course, very important. Is growing quickly. Knowledge-based system can be effectively used to support the design of industrial product, as I probably shown in the first part of the presentation. The database collects all information concerning the product design, or can collect, and the production and use. All artificial intelligence, together with inference engines, allow the extraction of possible versions of the product, combining materials with manufacturing technology, optimization techniques. Different possibilities are available. But again, the designer can quickly define feasible, effective alternatives of the product, but in this case, this is a work presented in 1986. It's quite a famous one. Before a simpler scheme was realized by Swift, the objective, the aim of knowledge-based engineering system is to increase the design freedom. It means that the design must be free to think only to the shape of the product without having the problem to think to the calculation, to the validation, verification, and so on. This is possible by means of knowledge-based engineering system if the knowledge is available in a preliminary phase of the product development. This is the meaning of this sketch. In this case, it's possible to reduce the committed cost, but if you look at the incurred cost, the line is the same. It means that possible modification of the product in this stage, particularly when you are close to the production, are really heavy in terms of cost. You cannot modify a project when you are already in this stage because the costs are so very high. And the important things is that knowledge must be available and in this part, the preliminary part of the proposal. But this is our proposal. Can be also thought by means of the example I showed. First of all, it is necessary to consider different type of design, because not only product design exists, and also you have to consider the complexity, the way you are representing the knowledge. In the example I showed, we used high-level computer-aided design templates, for example, and in our idea, the design freedom is reduced if you use this type of approach. You can save a lot of time, because the automation of the repetitive task, the repetitive operation. But you have to consider another variable that is very important: the time for coding and training people to use the tool. For example, I don't know if, for example, in the case of Siemens, it was so easy to train the people to use the virtual environment. So this is another aspect that must be taken into consideration. Smart integrated, I don't want to, I will go quickly through this part because you are very expert about smart system, but the idea is that also knowledge-based engineering system can be smart. It means have some interaction with the environment in order to achieve a smart KE system. This is really a complex table we realized some time ago after a lot of discussion among us. Is a comparison of the different approach. The smart system should be a KVA smart system. And I would like to underline just this part of the table. Is about creativity. The idea is that manual design enhances creativity by means of repetition. It means that if you repeat your design a number of times, the connection between the hand and head helps in order to enhance creativity. If you use a software system, creativity is limited. It's limited, for example, because you have to move the point of our system. You are not free to think in a 3D environment, but you are moving just points. And also the connection between hand and head is limited because you just move a mouse probably or something like that. If you use a knowledge-based engineering system, again, it is better to think that it is necessary to have tools in order to fostering and strengthening creativity. This is also a relevant topic concerning university education. In this year are increasing the number of courses dealing with creativity. Again, if you use a smart system, more or less is similar. Tools for fostering and strengthening creativity are necessary. Ability to connect the digital system is another important problem because is a sort of limit between generation. It's finished. This is the. I can comment every line of the table, but it's not the case. So thank you very much for your kind attention.
Thank you.